Having a basic understanding of the electrical system in the laying machine can be very helpful to you when troubleshooting problems. We have simulated a problem in the laying machine right now with one of the outputs, that output being the vacuum motor. You'll notice also that we have a digital voltmeter with us. Now, there are two types of power that we can check with this. We can check alternating current, which is what the laying machine uses, and we can also check DC or direct current, which is what our drive motor would use for the laying machine. We also have another option that allows us to check the ohms or resistance. And we would use this in checking a fuse, for example. And there are two settings for that on this meter. We also have one that has a tone. But right now we're going to check incoming alternating current. The first point to check would be the incoming power. Now, we have the machine unplugged, so we're going to go ahead and unplug this now. We're going to take our black lead and put that to the white or the neutral. We're going to take the red lead and put this to the red wire or power. We plug the laying machine in. We'll notice on the meter that we do have acceptable power coming in. We have 122 volts. So we're okay here. We'll go ahead and unplug the machine again. Remove our leads and plug that back in. We'll reapply power. From this point, we would recommend that you access your outputs through your test output key on your keypad. We're going to hit the test output key until we get to the output that controls the vacuum motor, which is output number 206. Now we have two output modules on the PLC. The first output module, which would be the center one, is going to control all of the 100 outputs. The second module is going to control all of the 200 outputs. So this is a module that will be controlling the vacuum motor, because the vacuum motor is output number 206. We will hit the on-off key on the keypad to turn the output on. And you notice we heard a click, and we also have a light on the output module. And the number that is lit up is 6. So we're going to check to make sure that the proper power is coming out of this output module and relay. We're going to take the black lead from the meter, and this time we're going to use the neutral off of our black light plug. We're going to connect that there. We're going to take the red lead and find the wire that goes to the number 6 output. And you have a bottom row of screws on the terminal strip and a top row. The bottom row is all odd numbers. The top row are even numbers. So we're at 0, 6. Starting with the first screw, it would be 0, 2, 4, 6. So if we put our red lead on that terminal screw, we can see that we have the appropriate amount of voltage coming out of there. So we have ruled out that we have a failure in the relay. Now we also have a breaker for this vacuum, but it has not popped up and appears to be okay. The next point to check would be the vacuum motor relay. There has to be power going into the relay and coming out the other side so that it can go to the vacuum motor assembly. We're going to leave the black power lead on the neutral for our black light plug, and we're going to take the red lead and put it on the screw for the gray and red wire. That is the wire color that goes to the vacuum motor plug. Now, if everything is okay, we should have 120 volts, which we do. So there must be a problem in between this terminal screw and the plug of the motor. And as we come over to the vacuum motor, we can clearly see that that motor is unplugged. We will now turn off the output so that we don't have any power going to the vacuum motor, and we can reach down, plug it back in. We can turn the output on to see if the motor works. Which it does, and the problem has been corrected. Other outputs in the lane machine are protected by individual fuses. We're going to show you how to properly check a fuse and start with the drive motor fuse itself. Now, I want you to carefully look at that fuse. This is not a normal glass fuse that most people would be used to. This is a ceramic coated fuse, and there is no way to look at this and verify that this fuse is good. The only way to check it would be with an ohm meter. So we're going to take our meter and turn it to the setting for ohms, and we're going to check for resistance in that fuse. You want to make sure that you don't do this on any type of metal surface. Okay, we're going to hold the fuse right in between the leads, and as we can see the meter change, we've got resistance. Now there is another setting on here that will tell you if a fuse is good or if you have resistance by a tone. If the fuse is good, we can rule that out as a possibility and move on to another area to troubleshoot.